Welcome back to my channel, and today in this video we are going to study about the probability calculation for dihybrid cross. Now, as we already learned that probability is equal to number of favorable outcomes divided by total number of outcomes. Now, to calculate the probability of a dihybrid F2 genotypic ratio, first, as we already learned about how to calculate the probability for monohybrid genotypic ratio. So how we calculate it? With the total events 4, 1 is to 2 is to 1. Probability of capital T is 1 by 4. Capital T small t is 2 by 4. Small t is 1 by 4. Now why I displayed this first? Because now it will be easy for us to calculate the probability in case of dihybrid genotypic ratio. Now these are the genotypes which are formed in the dihybrid cross F2 generation. Now, those who have not seen the last videos, I will provide the link at the end of this video. Go and check them once to know how we arrived with these genotypes. So now, the first genotype, that is capital R, capital R, capital Y, capital Y. Now, how we can calculate the probability for this? Now, if you see this capital R is like this capital T, that is the probability is 1 by 4. This capital Y is also like capital T. That means the probability again for capital Y will be 1 by 4. So for capital T, if it is 1 by 4, definitely then for capital R, it will be 1 by 4. For capital Y also, it will be 1 by 4. So therefore, the probability of this particular genotype, that is capital R, capital Y will be 1 by 4 into 1 by 4. 1 by 4 for capital R, 1 by 4 for capital Y. Together for capital R, capital Y, it is 1 by 16. So from here, from the monohybrid cross, it is easy for us to calculate the probability for dihybrid cross. Now, for the next genotype, that is capital R, capital Y, small y. You pause the video and try to find the probability by yourself. So for capital R, it will be 1 by 4. For capital Y, small y, it is like capital T, small t. So the probability is 2 by 4. So here it will be 1 by 4 into 2 by 4, that is 2 by 16. Now calculate for capital R, small y. So again for capital R, 1 by 4. For small y, it is like small t. So again 1 by 4. That means it is 1 by 16. For capital R, small r, capital Y. So here it is for capital R, small r, it is 2 by 4. For capital Y, it is 1 by 4. So it is 2 by 16. Now here again capital R, small r, 2 by 4. Capital Y, small y will be again 2 by 4. So here it will be 4 by 16. Rest is your homework. You calculate and let me know in the comment section what will be the probabilities for rest of the genotypes. Now, how we can calculate the probability for a phenotypic ratio of a dihybrid cross. So in case of phenotypic ratio, it is easy to calculate because we know the phenotypic ratio, that is 9 is to 3 is to 3 is to 1, that is total of 16. Now 9 is for round and yellow, so the probability will be 9 by 16. Round and green, it is 3 by 16. Wrinkled yellow, 3 by 16. Wrinkled green, 1 by 16. Now how we got these phenotypes? For that, again, you have to see the video for the dihybrid cross. Now, this is directly we can get from the phenotypic ratio. Also, if we want to calculate it from the monohybrid ratio also, from there also we can calculate like we did for the genotypic ratio. So, for round and yellow, round is a dominant one. So, here the probability for the dominant one in case of phenotype, it is 3 by 4. Yellow is again the dominant one. So again, the probability will be 3 by 4. So here it is 9 by 16. For round and green, round is a dominant one. Probability is 3 by 4 into green is the recessive one. So the probability is 1 by 4. So total is 3 by 16. Similarly, wrinkled is recessive one. Yellow is a dominant one. So here again 3 by 16. Wrinkled, the recessive one. Green, the recessive one. It is 1 by 16. So we can also calculate from the monohybrid ratio. So it is easy to get the probability for a dihybrid cross from a monohybrid cross results. Now one question, that is, if you have given this particular genotype, that is capital A, capital B, small b, capital C, small c, capital D, small d, and capital E. Now assuming independent assortment, what is the probability of having the gamete A, B, C, D, E? Now take one gene, because one gene is responsible for one character. So from capital A, we'll get only one type of gamete. But from capital B, small b, we will get two varieties of gamete. So from here, in the result, we are having this B, capital B. So 1 out of 2 outcome. Because from here we can get capital B also as a gamete and small b also as a gamete. But our outcome is capital B, favorable outcome. And the total number of outcome, 2. So 1 by 2. Similarly, for capital C, small c will be 1 by 2. Capital D, small d, 1 by 2. Capital E, only 1, because both the gametes will be E. So now it is 1 by 8. So here also it is same written. Now one more question, that is, 3 genes are present, A, B and C, controlling different characters and assorted independently. A plant with genotype capital X small a, capital B small b, capital C small c is selfed. What is the probability for progeny which shows the dominant phenotype for at least one of the phenotypes controlled by the gene A, B and C? So it is selfed. Selfed means the same is crossed with another individual with same genotype. Now we can go like a monohybrid cross, one character. So if we cross like this, how many genotypes we will get, right? And the probability will be then same for BB also. We will get capital B, small b, small b, small b. Probability will again similarly for clear. So now what is not allowed? Better to calculate in a reverse way. What it is saying, what is the probability for progeny which shows the dominant phenotype for at least one? So what is not allowed is this genotype, all the recessive one. Now AA, what is the probability? 1 by 4. BB again 1 by 4. CC also 1 by 4. So that means 1 by 64. Clear? This is not allowed. Rest all are allowed. So in the probability, it ranges from 0 to 1. So this is not allowed. So how we can get the allowed one? 1 minus 1 by 64. You can calculate this and you will get the result. It will be 63 by 64. So that's all for today's video. And I'm not giving you any question this time because already I have given you the homework. You have to finish that probability of dihybrid cross genotypes and let me know in the comment section. If you found the video informative, please do like, share and subscribe the channel and hit the bell icon for the next video notification. Till then, stay safe, stay happy.